Okay, so here we go. Unit 2, Topic 2. We're talking about solving equations with fractions. But before we get into all that, we need to talk about and focus on a couple of things. The easiest way to work with fractions is to find the LCD, that is the lowest common denominator. That is the smallest number that goes into all of the denominators. And it could be a couple of factors, it could be a number depending on what you have. And that's the easiest way to get rid of all of the fractions, because we don't like working with fractions. So we're going to talk about that, and then the second thing we're going to do is we're going to talk about finding the excluded values for a particular variable for a particular equation. So here's some information here. Any factor of a denominator in the set of fractions is also a factor of the common denominator. We're going to use this to make the lowest common denominator. To get that, we're going to factor all the denominators that are in the set of the fractions. We're going to factor those completely. We're going to look through those. If that factor is not part of the LCD already, we're going to multiply it into it. If the multiplicity of the factor in the fraction denominator is higher than that of the LCD, then we're going to need to raise the multiplicity. So a couple of things to keep in mind. Let's just take a look here. So the first thing I'm going to do is I'm going to break this down. So when you think about 6 is really 2 times 3. 3 is already broken down, it's prime, so 3 is 3. And 2 and b are both prime numbers as well, so you just have 2 times b. So when we look at all these, each one of them needs to be represented in the LCD. So the fact that you have a 2 over here and a 2 over here, but not one here, there needs to be one there. So basically, your LCD needs to consist of a 3, a 2, and a b. And so when you multiply all of those together, you get 6b. That would be your lowest common denominator. That would be basically the smallest number that all of these denominators go into. And then ultimately, what we're going to do is we're going to multiply both sides of the equation by this value right here, and that's going to cancel out every term in the denominator and basically clear all the fractions, and that's how we're going to handle that. If you come over here, you notice that in terms of breaking them down, we've got a 2 and an x. Here we've got 4 can be broken down, so this is 2 times x, and then this is 2 times x times x. Okay, so notice there's only 1 2 here, and there's only 1 2 here, but here there's 2 2's. So our LCD has to have those 2 2's. I'm going to write it as 2 squared. Here's an x, but here's 2 x's. So the lowest common denominator has to include the 2 x's, so x squared. So if I multiply all this together, or simplify it, whatever you want to call it, I get 4x squared is ultimately going to be our LCD. And once again, that's what we're going to end up multiplying everything by here. And when we do that, our fractions will all cancel out. And this is the fastest, easiest way to do it. Let's take a look at another example right here. Now here we see in the denominator, we need to, obviously we have some polynomials that we're going to have to factor. So when we take a look at this, obviously, whoops, my pen doesn't really want to behave properly here. So once again, I'm going to factor or break them down. So this is obviously just an x. But when I look at this right here, this can be factored. I can factor out an x, and when I do that, I'm going to be left with x minus 4. Okay? We're doing the same thing we did on the previous examples, only these were not polynomials. But the concept is the same. We're going to do the same thing here. I'm going to factor this. And I notice if I factor out an x, I'm going to be left with x minus 4. Once again, because these terms are the same as we can see. So when you factor them, their factors are the same as well. So in our LCD, every single one of these needs to be represented, and as you can see, they all contain an x, so that's got to be in our LCD. and that's fine. And then we see this has a factor of x minus 4, and so does this, but this one doesn't, but it does need to be in there. Everything needs to be represented, even if it doesn't have it. So our LCD would be these two factors. I can multiply it together and get x squared minus 4x if I want, or frankly, I could even leave it like this, and that may even be a better way to do it. Again, I'm going to end up multiplying both sides of this equation, or in other words, I'm going to multiply every one of these fractions by this LCD. Come over here. Very similar thing. We have some polynomials down here. What are we going to do? We're going to factor them. So once again, we notice we can factor out a 3. If we do that, we're left with v minus 6. Come over here. I notice there's a factor of 3v. I'm left with v minus 6. And over here, I have a factor of v, and I'm left with v minus 6. So making sure everything is represented, I can see I have a 3, so 3 needs to be part of my LCD. I certainly have a v minus 6. That needs to be in there. And then I have a v. Okay, so my LCD is going to be 3v times v minus 6. And once again, I would probably leave it just like that. And just like we said over here, every single fraction in this equation is going to get multiplied by this LCD, and that's going to be the easiest way to clear the fractions. So that's the first thing. The second thing is we need to talk about any excluded values for the variable in the equation. So any value for the variable that would cause us to have to divide by 0 in an equation or an inequality needs to be left out of the solution set. It can't be part of the solution because we know we can't divide by 0. That's undefined. And our solution set needs to only be those numbers for which x is defined. So any value of a variable that would cause a factor of a denominator to equal 0 will result in division by 0, and the other fact is the LCD contains all the factors of the denominator. So really what we need to do is we just need to find the values that would cause any LCD factors to equal 0, and then those are excluded from the solution set. So if we go back to this, we already did this problem right here when we said that the LCD would be 2 times 3 times b, so it would be 6b. And then all you really need to do is you need to set that equal to 0 and solve for b. So if we want to solve for b, we'd have to divide both sides by 6. That gives us b equals 0. And so that's an excluded value. B is not allowed to be equal to 0. If you think about it, if I were to plug 0 in up here, I would have 2 times 0, which would give me 0, and then I'd be trying to divide by 0, which we can't do. And so that's why that's an excluded value. It cannot be part of our solution set. B cannot be 0. Let's come over here and take a look. You recall from the previous a few slides ago when we did the LCD here, it was going to be 4x squared. Okay. Once again, you would do the same thing. You would set 4x squared equal to 0. All you need to do is once again divide or solve for x. Here we could divide both sides by 4. That gives us x squared equals 0, and then you would, this is just going to be a double root. You would technically take the square root of both sides here. You would get x equals, whoops, really did a lot of damage on that one. So you would take the square root of both sides, and you would get x equals positive and negative 0. So you would actually have a double root right there. But it's as you can look up here, obviously x or 0 is the only value that can't be part of the solution set, because if we were to plug it in here, that would give us 0. If we were to plug 0 in here, that would give us 0. And then 0 squared would be 0, and then 0 times 2 would be 0. So either way, no matter where you plug it in, no matter how you slice it, x can't be 0, so that can't be part of our solution set, because then we would be dividing by 0. Let's take a look at this one here. So our LCD was, let me take a look here. When we factored this out, we were left with x minus 4. Same thing over here. So this time it looks a little bit different. So remember how I told you to leave your LCD like this? Well, now that we want to find the excluded values, we just set this equal to 0. And we know from previous experience, when we've been trying to solve a quadratic by factoring, we would get something that looks like this. We would set both of these equal to 0. And we would get our two solutions. But in this case, we're not looking for solutions. We're actually looking for excluded values. It's very similar. So this is already solved, 0. This is going to give us 4 when we add the 4 to the other side. So we just found out that we have two excluded values. X cannot be 0, and also x cannot be 4. If you were to plug those back in up here, you would see that plugging in 0 here would give us a 0 in the denominator. It would cause a problem here as well, and so would 4 if we were to plug in 4. 4 squared would give us 16. 4 times 4 is 16, so you'd end up with 16 minus 16. That would also give you 0. So those would be your excluded values. Okay? Same thing would happen here. What's this look like? You get this. Okay, that's what it looked like when we factored all those. So our LCD ended up being 3v times v minus 6. You can do the same thing. You're going to set that equal to 0. And then you're going to get 3v equals 0, and you're going to get v minus 6 equals 0. And then you solve them both. I'm going to divide by 3. So that's going to give me v equals 0. That's going to be one of my excluded values, and this is going to be v equals 6. So those are my two excluded values. All right, so that's part 1.